Greetings, everybody. So welcome back. We're going to take a look at another example of finding the second derivative of a parametric equation. So here I have x of t equals cosine of t and y of t equals sine of 2t. So to start, I'm going to first figure out what dx dt is. So dx dt, the derivative of cosine of t is going to be negative sine of t. And then I'm going to find dy dt. And so the derivative of sine is cosine of 2t. But then I have the chain rule that I need to apply because I have a function inside of another function. So I need to multiply by a factor of 2. So now, to find dy dx, the slope of the actual path of my trajectory, I need to find the derivative of y with respect to t, and then I need to take that and divide it by the derivative of x with respect to t. And that will produce my change in y for a change in x. So dy dt is going to be 2 cosine of 2t, and dx dt is going to be negative sine of t. All right, and so now that I have dy dx, if I go and try to find my second derivative, I am going to need to find, for my second derivative of y with respect to x, that's going to be the derivative with respect to t of the first derivative divided by dx dt. You can take a look at an earlier video as to the conceptual framework for y. Hopefully that will make some sense. The basis of that is this idea that, as you can see here, the derivative of y with respect to x is a function of time, and therefore I need to apply the chain rule when I am taking the derivative of it. And so here we go. Let's go ahead, and since my first derivative has a quotient of two functions, I need to apply the quotient rule. All right, so I'm going to first just put a division symbol here, and I am going to take the derivative of the top function. So the derivative of 2 cosine of 2t would be negative 4 sine of 2t, because I need to apply the chain rule again. I had another factor of 2 that I'm multiplying by as a result of that chain rule, times the denominator's function, so that would be times negative sine of t. And then I need to subtract from that, keep our top function, and the top function is 2 cosine of 2t, and I'm going to take the derivative of my bottom function. And so the derivative of negative sine of t is going to be negative cosine of t. All right, and then we divide that by the bottom function squared. So that's going to be negative sine of t, quantity squared. So that's just my numerator here. That is just this portion up here. That is the derivative of y with respect to x, and I'm going to take the derivative of that with respect to t. Okay, so that is d dt of dy dx. Now I need to divide this. I need to divide this by our value for dx dt. And we said that dx dt up top here, dx dt is negative sine of t. So I need to divide by that dx dt. So here we go. So this would be divided by negative sine of t. Now, if we want to, we can simplify this, but we don't necessarily have to. It depends on what your purpose is. And so I'm just going to leave it in its unsimplified version. but it wouldn't be too big of a deal to simplify this. All right, so in the next video that we'll take a look at, we're going to explore the idea of concavity as it relates to parametric equations. So join us in a little bit. Thanks and have a great one.